Hi, this is Tara Andrews, Analytics Sales Manager for the North American Midwest. Thank you for joining our latest Live from the Lab, where we'll be showcasing a UFDF run monitored by concentration, not weight. Joining us today are my very knowledgeable colleagues and field application scientists, Brandon Goldberg and Jeremy Neider. Today is meant to be an interactive experience. So please use the control panel on the side of your viewer to submit your questions throughout the presentation. The control panel is where you can access your audio options as well as into your questions, but please note, it will collapse when not in use. Okay, our experts will do their best to get all the questions answered during the Q&A segment, but if we run short on time, we will email you after the webinar with the answer. All right, while we're waiting for others to join, let's give them about 2 minutes. We'd love for you to participate in our first poll question. Once you've done answering the poll, please click submit to send us your answer. We'll be back with you momentarily. Awesome, thank you for your participation. Now, let's get started with the Live from the Lab demo. I'll now hand this off to Brandon Goldberg.
Hi everyone, thank you so much for that introduction, Tara. As she mentioned, my name is Brandon Goldberg. I'm the field application scientist for the FlowVPX inline. So here today we will be talking about the FlowVPX, basically connected to the KR2i TFF system, and we'll be doing a standard TFF run using 100 mg BSA. I have my colleague Jeremy Neider here to go over the KR2i.
Hi, I'm Jeremy Neidert. I'm the field application scientist with Repligen, supporting downstream technologies. So as Brandon already mentioned, right now we have a KR2i system as our bench scale TFF system. Like most TFF systems, this is a series of pumps and scales, but the special part is how it talks to each other. So the scale is monitoring your feed weight over here, which can give you a concentration off of that, but we actually have a VPX here that's giving us our concentration. We have our main pump here that is providing our cross flow or a tangential flow to this, as well as a flat sheet filter over here. And this is providing our, our filter here. Connected to the filter, we have pressure sensors on our feed, retentate, and permeate side here as well. And this all feeds back and into the software, as well as on the screen here to show you an output of where your pressures are, as well as calculate a TMP, which actually comes back into this automated back pressure valve that we have up here on your retentate. So this is what allows you for part of the automated TFF that we're running here as well. So everything, the pumps, the feed, the permeate scale, all of this is going back into our software here where we can control and program methods in here as well. So I'll hand it back to Brandon. We'll get into this a little later.
Perfect. Okay. Thank you, everyone. So basically now what we're going to do is I'm actually going to start the run and show you the software that controls the FlowVPX system. Okay. And just to explain that before we actually get into our PowerPoint slides is, as you can see here, this is Viper, which is, it's app-based, and this is the app that controls the FlowVPX. On the left side, you can see this is the method you would set up to actually do your run, which for our method, what you would need would be the wavelength of interest, the A280, and then also your extinction coefficient for the material you're working with, which today we are using BSA, so the extinction coefficient would be 0.667. And then, of course, this is rounded. And then, as you can see here, we have a title, Live from the Lab, and I'm just going to press this green button to start the actual method. So as I mentioned, we are going to be using 100 mg BSA. So we're just going to wait about 5 to 10 seconds for how long this method will pull up the data point so that we can see the actual concentration. And once this starts, I'm going to unblock the permeate so that we can stop recirculating and start concentrating up. Okay. Okay, so while this is going to be going and concentrating up, we're actually going to present to you today a couple slides on the FlowVPX and the KR2i system itself. Okay. Keep going. So for everyone who doesn't know about our technology, is the FlowVPX is an inline uv-vis spectrometer where it gives you the ability to measure concentration in line. So the FlowVPX can go anywhere from 0.1 mg per mil to over 300 mg per mil at a 1.5 extinction coefficient. Okay, so this gives you the ability to increase process understanding, reduce cycling time, strengthen your process control, and minimize risk. Okay. The FlowVPX can also is very scalable for your process. So we can go anywhere from lab scale using the 3mm flow cell all the way to 2-inch custom-made flow cell for manufacturing. The sizes we have in between would be 3mm, 10mm for pilot scale, 22mm for production scale, and again, like I mentioned, up to 2 inches. We also have single-use flow cells as well as 316 L-grade stainless steel that can be cleaned and autoclaved. Okay, so going back to how our technology actually works, compared to traditional UV spectroscopy that uses a 1 centimeter cuvette, and again, uses a light that's horizontal, and which makes you have to dilute and you have to actually fit your concentration to the traditional UV spec, you no longer have to dilute using the FlowVPX due to its variable path length spectroscopy. Okay, with our variable path length technology, we're able to go from 1 micron all the way up to 5 millimeters. And this gives us a wide range of concentration while running everything neat. Okay. We are able to do this because we rearranged Beer's law to incorporate slope. So M, which is the symbol of slope, is the change of absorbance over the change of path length equals the extinction coefficient multiplied by concentration. So as long as you have your extinction coefficient, you will be able to solve for your slope using the FlowVPX and calculate your concentration. Okay. So the FlowVPX is mostly used in downstream applications. I have listed a few on the screen right now. Today, however, we will be focusing on UFDF, the TFF process. But again, many of our customers do use it for chromatography, UFDF, bulk drug substance, concentration formulation, sterile filtration, and fill finish. Okay, but like I said, as you saw earlier, we have it currently on a TFF system. So for the FlowVPX, you would normally put it directly after the feed vessel on the feed line, and you would make sure that the feed vessel has mixing inside, so you're reading a homogeneous sample. The solution would then go into the pump, into the membrane, and circle right back into the retentate line. By doing this, you would then be able to see the concentration clearly as you concentrate up or do a diafiltration. Okay, I'll let Jeremy talk about the KR2i.
Hi, this is Jeremy again. So the KR2i TFF system is, like I said, one of our benchtop TFF systems here. So the KR2i uses a peristaltic pump head, whereas also we have another system, the FS15, that has a quattroflow pump head on it. But the general concepts remain the same there, as well as the KR2i and the FS system, which is about a 10 mil to 10 liter. We also have scaled up pilot scale systems as well. So the controls that we talked about earlier are what allow us to create a more scalable process at this benchtop scale there. So the controlled shear or cross flow rate from the main pump is just one of your parameters, as well as the automated TMP control valve allows you to hold that TMP constant as you concentrate or increase viscosity, or even as you diafilter and maybe your viscosity changes as well. That automatic back pressure valve that's up on the top at your retentate is allowing you to kind of have hands-off process there, as well as to keep that variable constant, so that way when you scale, you're scaling with like-to-like processes. So the system all runs off of this tablet that is above there as well, and so that tablet allows really easy and flexible programming for different protocols or methods that you can set up and actually run your process pretty hands-off. So for concentration modes, it can either use that scale weight from that feed scale that's on the left there to understand your concentration, but even better, we can use the FlowVPX there to actually have direct concentration input and control to specific concentrations there as well. The diafiltration aspect of it actually uses an auxiliary pump that automates the buffer addition. So that's hands-off. So as your flux changes throughout the experiment, your buffer addition maintains at a constant weight there on the feed scale there for that really truly walk-away automation. So by increasing all these controls that you can actually have at the bench scale system, this allows you to minimize the risk while scaling up from a process size. And we also offer fully customized flow paths that are gamma irradiated for plug-and-play sterile operation as well. So that's a little bit of background on the system as well. So I'll hand it back to Brandon.
Perfect. So as we went over the technology now, I'm just going to show you some different data that our customers have achieved throughout the years and some data that I've done myself as well. So first, this is just an example of ultrafiltration 2. So our customer started at 50 mg per mil and concentrated all the way up to about 230 mg per mil. As you can see here, the FlowVPX compared to the FlowVPE, our older inline instrument, and the SoloVPE, our offline instrument, were all very comparable. Okay. And again, so this was the same thing, just going through all three of our platforms, our inline and our offline instrument, just at a lower concentration, comparing the UF1, the diafiltration, and the UF2. Okay. So this was another very similar run where the customer started at 10 mg per mil and concentrated all the way up to 260 mg per mils, which we then compared it to offline A280 and the SoloVPE. I do want to note though, using the offline A280, as I'm sure you're aware, you would actually have to dilute the sample to be able to read that one. With the FlowVPX and the SoloVPE, you can just take off the sample and read right away, which saves a lot of time. Then going over this data, this is actually quite different. So this I ran myself, again with BSA. I started at 10 mg per mil and went up to 50 mg per mil. However, this is something we did more for the future. So instead of just using the FlowVPX for protein monitoring, I actually hooked it up to the KR2i and did it for protein control concentration. So basically what happened was I created an algorithm where at certain points of the way I would concentrate, or the system would change and turn off the pump or recirculate the pump to have a fully automated system based off of concentration. So as you can see, my goal was to set diafiltration at 20 mgs and then concentrate all the way up for UF2 to 50 mgs per mil. And when you compare what we did with the automated TFF compared to standard mass calculation TFF, it is much clearer that going off of concentration actually gives you a lot better result, just because you don't have to calculate the holdup volume, you don't have to make sure that the scales are set or anything. The FlowVPX is just fully automated and does it all for you. Okay. So as we just talked about the actual system and technology a lot, which actually went pretty fast, I do want to go back to the software screen and actually the system itself and just show you guys so you can still see kind of more of it like a demo and see what's actually happening with the system, which you can see here, the BSA, which is currently mixing in the system and just recirculating. So since we started, which was only about 15 minutes ago, we already went from 100 mgs per mil to now 110 mgs per mil, which if you can see, it's currently right here. I know it's kind of hard to see when it's split screen, but there you go. So it's about 110 right now. And again, so we're gonna let this concentrate up for the whole time we are here. So I will like to put it back to Tara. Whoa. Yep. Okay.
Okay, great. Okay, interacting with you is what makes events like this so great. Please submit your questions if you haven't already done so. We want to hear from you, and our experts are standing by. So I'll give you a couple minutes to get your questions entered into the control panel. So go ahead and do that now.
Any questions, or if I missed something about the system, just ask away. I mean, I see that we have plenty of time today. So again, it's mostly for you guys to focus on the instrument itself and see how it actually works for a UFDF setup. Okay. And just since we're here, I would like to explain the software a little bit more. So if we make this full screen, I just want to show you how you actually have multiple graphs. So you have the concentration versus time graph. You have the slope versus time graph, which you can actually click on a data point and you can see the slope that you're getting, which you want to make sure it's pretty linear. And then that last graph is what actually measures the linearity, which is r squared versus time. So you want to make sure that you have 3 nines or higher to have passing data, which we do. And please don't be aware or afraid that it's jumping up crazy. If you look at the scales, it's actually very, very small. So it's 0.9999 to the 8th. So again, it's actually moving just very little.
Hey, Brandon, will you explain how these systems are connected or talking to one another?
Yep, great question. So actually, how the systems are connected, so if we go to the side view of the cameras, the system is actually connected just through barb fittings right here. And basically, that's how you connect it physically. However, we do have an option with the KR2i called the conduit, and using the FlowVPX, which uses an analog output. So you can do 4 to 20 milliamps or 0 to 5 voltage, and even OPC UA to connect to different types of UFDF and chromatography skids if you would like to. Again, if we wanted to connect to the KR2i today, we would just use 4 to 20 milliamps connected to their conduit to send all of the data on their actual tablet today instead of seeing it all on just 2 different computers. And we have worked with many different systems to do this. Okay.
Okay, so we've got tons of questions, and I hope that we have time to get to all of them. It looks like we should. The first question we have here, can you monitor extinction coefficients larger than 1.5? We are evaluating a protein with a larger extinction coefficient. If not, why?
Yes, so you can actually use many different coefficients. The reason I said 1.5 is because we did our testing basically with a standard MAB at 1.5. However, we have customers that use this for all different types of materials, whether it be oligos, DNA, AAV, that go anywhere from an extinction coefficient of 24 and all the way down to, like you said, BSA with a 0.667 extinction coefficient. So we can use wide ranges of it. You just have to know that with Beer's law, it is extinction coefficient based. So depending on your extinction coefficient, you may not be able to go high as, say, 300 mg per mil or higher, because the higher the extinction coefficient, the lower in concentration you'll be able to go.
Okay, great. Next question. Can the VPX collect 2 wavelengths at a time?
Great question. So actually, if you look in the software, I will show you real quick. You can actually choose, there's this plus sign right here. I cannot do it sadly right now because I'm in the middle of a run, but you can choose up to 10 wavelengths to run in your method. And we also actually will have the ability to do a spectrum scan in real time too, which using the Agilent Carry 60 will go from 190 nanometers to 1,100 nanometers. But you do have to know that for every time you add a wavelength or you're going to do a spectrum scan, it does add time to the method. So the fastest method we do to produce data would be about 5 seconds. Note that for every wavelength you add, you would want to either double that time. So for 2 wavelengths, 10 seconds, and so on. It really depends on the method that you create.
Okay, thank you. Next question. Have you done any work to do integration of your Viper software with other automation packages such as Delta-V? This is with a view for GMP operations.
Correct. So we have actually. So like I mentioned, it really depends on the delta V version you're talking about, because for delta V, it could either be connected with analog output, so 4 to 20 milliamps, or if you have a newer version of delta V, Viper software has an OPC UA server that can connect directly to delta V. So as long as you have, I think it's version 14 or higher, you can use OPC UA. If it's version 13, you would use analog output. But yes, we do have it connected with some of our customers. Others have used SynthIQ, OSI Pi, things like that.
Okay, great. How quickly is each concentration measurement taken?
So again, this is dependent on the method. However, if we go to the software, so you can see here, it's been, oh, Candace, can you please switch to Viper? As you can see here, we've been running for about 16 minutes now, and we had over 61 data readings. So with this method, it's taking about every 8 seconds because of the fact that I am using 7 data points. But you can decrease this, as you can see here, up to 5 data points, and it should be about roughly 5 seconds per concentration reading. However, if you want to actually get very specific, you can click on this, and so we're taking, like I said, 7 data points per slope. You get about 1 data point per second, which will calculate to about 8 seconds for an actual concentration data point.
Okay, great, thank you. Are there issues with diverting flow? At manufacturing scale, we won't be able to send all flow through the flow cell. Some will have to be diverted and then returned to the main.
That's not a problem. Some people use Y columns where, again, they will recirculate one path and then put it in through. Again, you just want to make sure that the flow cell stays full and it doesn't go from wet to dry, wet to dry. But as long as you still have something in there, it is fine.
Okay, great, thank you so much. Assume a spectrophotometer is needed with the FlowVPX. How does that work with a chrome skid in production?
So you can kind of see it in this camera. So basically, we have the FlowVPX, which usually gets mounted on the skid. But like I mentioned, we use Agilent KR2i as our light source for now. We are looking to different solutions in the future, but we actually have this stainless steel cart right here, which this, depending on your cables, can be within 6 meters to 3 meters of the FlowVPX. Some people, however, instead of using our cart, does mount the KR2i to their actual skid in like a waterproof container and can do it that way. But yes, you will have to have the traditional uv-vis, which uses the fiber optic, which you guys can see right here. This is the fiber optic that's bringing the light from the KR2i to our system. And that, depending on the cable you get, would be from 3 meters to 6 meters long.
Great,
But
thank you so much.
Customers, oh, sorry, Tara. I've had customers outsource a cart or build a system with strong arm to get their like KR2i or laptops, PLC and all that safe and waterproof to be used in a GMP manufacturing suite.
Okay, can you clean the FlowVPX in line along with the rest of the system? Also, what material is the measurement chamber made of? Thanks.
Yep, perfect. So that's a great question again. So basically, yes, you can clean in line. I have done a study myself using 0.5 sodium hydroxide. And basically, I flowed that after a dirty hold of 24 hours with 100 mg human IgG. I flushed that at a very slow flow rate, about 35 mils a minute for 30 minutes. And then I did a TOC swab test, which for GMP cleaning results, it needs to be less than 500 parts per billion. And if you look at the data, which we can send to you guys if you are interested, we all had less than 200 parts per billion for the different flow cells I tested. So it is very cleanable in line. Like I said, you'd usually clean the flow cells with the same material you're cleaning your Pro A columns or your filters, whether it be 0.1 molar sodium hydroxide up to 2 molar sodium hydroxide. For the actual materials of the flow cell, the stainless steel flow cell is, again, it's 316L grade stainless steel and uses an EPDM diaphragm inside it. And then we will also have single-use flow cells as well, which will be a type of plastic. Okay.
Okay. Regarding concentration measurements, my understanding is that it works the same as the Solo VPE. Does this use a disposable fibrette like the Solo VPE? What are the consumables?
Okay, so you are correct as it works similar to the Solo VPE. However, unlike the Solo VPE that is offline, we do not have a disposable fibrette. So as you can see, actually, I can pull it up right here. This is what we would be using as our consumables. So this guy is called the flow cell, and this is the fibrette here. So instead of using the disposable fibrettes, we actually use a fibrette that's encased in stainless steel. Okay, so this guy can be used many times. Again, you would just have to clean it with your process unless you were using the single-use flow cells, but you would not have to throw it away at all. We also do replace these guys once a year. We give you a free one with the PM you purchase with the instrument. So you would choose the size of the flow cell that you would like and get it free with the PM. Besides that, there are 2 parts that you really have to be careful about. Is there's a glass window and then the seal that's inside there, the EPDM seal. Those would be the only 2 parts that would eventually, again, wear out, or say if something happened, if you dropped the flow cell on the ground and the glass broke, you can replace that, and of course the stainless steel body would always be perfect. But we do try to cycle them out once a year so that you'll get a free one with your PM. Okay?
Okay. How do you control the pumps based off the determined concentration from the FlowVPX? Is it part of the software?
That is a great question. So as I was talking about what I did using concentration as a control, that is currently not released. That is something in R&D that I was doing in my own lab, since luckily I have the ability to use both Repligen systems. However, right now, when you connect with the conduit, whether it's 4 to 20 milliamps or OPC UA, you would just use it as protein monitoring, and you would not control the pump off that.
Okay, great. Can it be integrated with our existing system, or does it need its own computer?
It really depends on what your system is. Of course, because we have certain specs for our software. We have downloaded software on other computers before and integrated it as one system. However, the majority of computers, because say it's a PLC instrument, would have our laptop that controls the actual FlowVPX, and then you would use OPC like Delta V to actually put the software on your, say, PLC computer and control it through there. But you would have both computers inside the lab.
Great. Can it generate a compliant report?
Yes, it can. So our software is GMP friendly. It's 21 CFR part compliant. If you make it using a security software, you can create a PDF with it. If you're in lab scale, you can send the data to Excel to manage all the data through there and things like that.
Okay, great. The next question is for Jeremy. Could you elaborate on the differences between the KR2i system and the FS15 system?
Yeah, yes I can. So the KR2i system and the FS15 system are at a base pretty much exactly the same here. You have similar scales, similar auxiliary pumps, and the main difference is that we are using a quattroflow pump head on the FS15. So again, that's your main control there as well. So it is a dedicated, the FS15 at its base is the unit down here. And the quattroflow pump head on there as well is a single-use quattroflow pump head on there as well, but that's really the main difference there. There's other small changes in there. The FS15 was designed and intended for the use with flat sheet filters, whereas the KR2i has, the flexibility, built in with the stand for the hollow fibers, as well as the peristaltic pump for the low hold up volume there. So the FS15 has some small changes where the back pressure valve is a larger back pressure valve for larger tubing that can withstand higher pressures, as flat sheet operations actually are more efficient at that higher pressure that the quadraflow pump head is able to hit. And so for that, the valve here is a little bit bigger to accommodate that tubing, as well as we stick it actually even down here as well and not on a stand, so that way it's closer to your outlet here and you can reduce hold-up volume in that manner. But as a base, it's pretty much the same. Runs off the same exact software, same pumps, and same scales there as well. You can run either a 20 kilogram scale or a 60 kilogram scale on there as well. The scaled up version of the FS15, the FS500, actually has a flow sensor that you can use for your permeate instead of a scale as well, which is pretty neat.
Okay. Perfect. Tara, sorry to just block you off real quick. Can we go to the software just so we can check out how the actual run is going? So as you can see here, we have a nice incline slope. So now it has been about 26 minutes since we started, and we are already at 130 mgs per mil when we started at 100. So it is increasing nicely, but thank you. I just wanted to show that real quick before the next question.
Okay, the next question is for Jeremy again. Can the conduit, and we might want to explain what that is, can the conduit link to an ACTA or other system, or is it dedicated for the KR2i system? And does the KR2i system have to be used? Does it have to be a UFDF system from Repligen? Okay, a lot there.
The conduit is dedicated to the KR2i. The conduit is our conductivity measurement system, as well as the UV input as well, or 4 to 20 milliamp input. But no, the conduit is not a standalone unit as it is. It uses a flow-through conductivity sensor, but it all feeds back to the KR2i system. So it is our proprietary connection in there.
So, and I do want to mention for the other half of that question, basically, we can connect the FlowVPX to the ACTA Avant or different ACTAs. So yes, for the KR2i, we use the conduit. However, the FlowVPX in general just uses 4 to 20 milliamps or 0 to 5 voltage. So for like the ACTA Avant, which uses 0 to 2 voltage, you can connect that directly to the FlowVPX and actually get the concentration into your ACTA Avant.
Okay, great, thank you. Does the Carry 60 cart have a cable management system option?
Yes, it does. It's kind of hard to see because sadly, on the other side of the lab is kind of messy. But all the cables will be built into the cart except for the ones coming out to connect to the FlowVPX and the laptop. So for cable management, it does help a lot compared to the standard U-line carts that a lot of people like to use in their PD labs. So this cart does definitely help with decreasing the size of the actual system due to the fact that the cart has the Carry 60 standing vertical and is only about 12 inches in width, so kind of like an airplane cart compared to the U-line carts that are ginormous.
Okay, great. Does this communicate with the KR2i software to control concentration factor?
So as I mentioned earlier, it does communicate with it. However, as of right now, you cannot use it as a control. It just does it as protein monitoring. In the future, we are working on that where in my lab, I am able to use it as control, but right now that is strictly for R&D.
Okay. Have you tried connecting this instrument to an ACTA crossflow where possibility of adding any extra tubing between membrane and ACTA is minimal?
Yep, so I have a few customers that actually use the FlowVPE, the older system, or the FlowVPX on an ACTA crossflow. Again, as long as you try to put it directly after the retentate vessel or your feed vessel, whatever you would like to call it, it should be perfectly fine. Again, I know there's a lot of times, depending on the system, there's not a lot of room going from the feed tank to your membrane. So another place you could put the FlowVPX is directly after your membrane. However, you have to realize that when you're taking an offline sample, you should recirculate first so that everything's homogeneous, or else the FlowVPX is always going to be reading slightly higher concentration due to the fact that it's coming directly off the membrane.
Okay, great. Thank you so much. What challenges are seen with pressure when using the FlowVPX inline?
Usually you do not see an increase in pressure or have the pressure drop at all when you have the FlowVPX inline. We have tested this, so we have some data that we would be able to send to you, but it was basically zero, or it increased once you got over about 300 liters a minute, and that would be the only time you would start to see a problem. And again, it wasn't really even a problem. You would just see a little bit change in pressure, but like I said, it was very, very little.
Okay, great. Thank you. Is it possible to collect full spectrum data continuously over a time frame?
Yes, so we do have a beta app. So as I mentioned, Viper is a software that works off of different types of apps, which I can actually show you if we go back to the computer. So if you look here, if I go back to the home screen, oh, sorry, that is my audit log. You have a bunch of different apps that can be used for the Viper software. So as an example, QuickSlope would be used for the Solo VPE. Quick Kinetics is for the FlowVPX. And so we do have an app here that will be focused on doing spectrum scans in line in real time. Okay.
Next question. You mentioned FlowVPE can be used with the crossflow. Can it also communicate with it, e.g. send an information that the target concentration to start diafiltration was achieved so that the crossflow starts the diafiltration?
That more depends on the capabilities of the crossflow itself. So the FlowVPE as well as the FlowVPX both use 4 to 20 milliamps or 0 to 5 voltage to connect to the crossflow, but it would depend on the crossflow side to see if it can control off its UV information. So basically what would happen is we would send the UV and concentration signal to the crossflow, and you would set up your method from there depending on what you would want to do with it. Sadly, I do not have a crossflow myself, so I would only know what the customers have done specifically. I've never actually used it myself.
Okay, great. Thank you so much. Is the flow cell autoclavable?
Yes, it is. So the flow cell is autoclavable. Again, we have certs and data on this as well that we can send to you if you guys are interested. So you could either clean in place, you can unload the flow cell from the FlowVPX and autoclave them as well, if you would like.
Great. All right. So thank you so much. Now we have a question for the audience. Please take a moment to complete our last poll question. Once you're done answering the poll, click submit to send us your answer. Okay, we had a terrific time with you today. If we didn't get to your question, note we had a lot of great interaction, but not a lot of time. So your answer will be on its way shortly. Just keep an eye out on your inbox. And if you're interested in learning more, please feel free to reach out to us. Our contact information can be found in the directory shown here, with the North American sales managers listed on the left, the Europeans in the middle, and the rest of the world on the right. Please let them know that Tara, Brandon, and Jeremy sent you. Thanks again for joining us, and we look forward to connecting with you again soon. Have a great rest of your week, and we'll see you next time in Live from the Lab.